Planck black hole. This is the smallest black hole physics allows to exist, so small that a single proton looks like Jupiter next to it. Its temperature? 10 quadrillion times hotter than the core of the sun, making it the hottest anything in the universe can physically be. But its lifespan is the real mindbender. Take the mayfly, the shortest-lived creature on Earth. It survives about 24 hours. Next to a Planck black hole, that mayfly looks immortal, like it's been alive since the dinosaurs. Think about it this way. A lamp flicks on across the room, and before that light even reaches your eyes, trillions upon trillions of Planck black holes could already have formed and vanished, blinking into existence, and gone before the idea of time even applies. This one disappears almost instantly, but the next one on the list, it might have survived since the beginning of time itself. Primordial black hole. In the first fraction of a second after the Big Bang, before any star, galaxy, or planet existed, the universe was a chaotic, unimaginably dense ocean of energy. In some regions, that energy became so concentrated that space-time itself collapsed inward, forming primordial black holes. Some are barely half a millimeter wide, roughly the size of a single grain of sand, yet weigh as much as Mount Everest. An entire mountain, compressed into something small enough to get stuck under your fingernail. Unlike the Planck black hole, which vanished almost instantly, a primordial one could still be out there right now, quietly drifting through space. Every object so far on this list needed matter to form. The next one breaks that rule completely, because under the right conditions, even the light illuminating the room around you could collapse into a black hole. Kugelblitz. A Kugelblitz is a black hole made entirely of light. Not a dead star, not crushed matter, just pure light, compressed so intensely that a black hole forms anyway. And according to Einstein's theory of relativity, this should genuinely be possible. The universe doesn't care where the energy comes from, which raises an uncomfortable question. What if humanity accidentally created a black hole of its own? Micro-black hole. Before the Large Hadron Collider switched on in 2008, a small number of physicists raised a concern that if the energies being generated, the collider might accidentally create a micro-black hole. The scientists running it weren't worried, and they had good reason not to be. Any micro-black hole formed at those energies would be smaller than a proton and evaporate almost instantly through Hawking radiation. And every single day, cosmic rays strike Earth's atmosphere with energies far greater than anything the LHC can produce. If micro-black holes could form and consume matter, nature would have already created them billions of times over, and Earth simply wouldn't still be here. This one is harmless. The next one on this list is not. In fact, if it appeared close enough to Earth, you would never finish watching this video. Stellar mass black hole. A star dozens of times more massive than our sun burns through its fuel over millions of years. Then, when that fuel finally runs out, its core collapses in less than a second, faster than the human nervous system can even register pain. The outer layers explode outward in a supernova. What remains is a stellar mass black hole, dozens of suns compressed into something smaller than Manhattan. But what happens at the edge of an object so dense that not even light can escape it? If someone watched you fall toward the black hole, they would never actually see you cross the edge. You'd appear to slow down, freeze in place, and slowly fade into darkness. But from your own perspective, you keep falling completely normally, feeling nothing unusual as you cross the boundary. You'd simply be inside, no way out, no way to tell anyone. So what happens when a star gets too close to one of these? X-ray binary black hole. A stellar black hole becomes dramatically more dangerous when it drifts too close to another star. Its gravity begins tearing gas straight off the star's surface, dragging it into a spiraling disk of superheated plasma millions of degrees hot. That disk blazes with X-rays powerful enough to be detected clear across the galaxy. These violent systems are known as X-ray binaries. The most famous is Cygnus X-1, around 7,200 light-years from Earth, where an invisible black hole is slowly consuming a companion star until the entire star is gone. That's happening in our galaxy right now, but not every black hole stays attached to a star. The next one could drift silently through our own solar system, and we might not notice until it was already too late. Rogue black hole. Some black holes are violently thrown out into deep space the moment they're born. A supernova explosion can push harder in one direction than the other, launching the newborn black hole across the galaxy at millions of kilometers per hour. No star, no light, no warning, just an invisible stellar mass black hole drifting silently through the Milky Way. These are known as rogue black holes, and there could be millions of them wandering our galaxy right now. Most remain completely invisible. We only notice them when they briefly pass in front of a distant star, warping its light before vanishing back into the darkness. In 2022, astronomers confirmed the first definitive detection of one, just 5,000 light-years from Earth, likely drifting silently through space for millions of years without anyone knowing it was there. But sometimes two black holes cross paths, and when they finally collide, the violence is almost impossible to comprehend. Binary black hole. When two black holes become trapped around each other, they slowly begin spiraling inward. As they orbit, they release gravitational waves, ripples spreading through space-time itself. In the final moments before collision, they're orbiting each other hundreds of times every second, at more than half the speed of light. When they finally collide, the merger releases more energy in a fraction of a second than every star in the observable universe combined. In 2015, scientists detected the first confirmed gravitational waves from exactly this kind of collision, using the LIGO observatory. The signal came from two black holes merging 1.3 billion light-years away, yet by the time the wave reached Earth, it moved our detector by less than the width of a single atom. We detected one of the most violent events in the universe through a distortion smaller than anything human beings can see. And despite all that violence, these black holes are still tiny compared to what comes next. Intermediate black hole. Somewhere between ordinary stellar black holes and the largest black holes in the universe, there appears to be a missing category. Objects too massive to form from a single collapsing star, yet far smaller than the cosmic giants discovered elsewhere in space. We call them intermediate black holes, and despite decades of searching, we found only a handful of possible examples. Scientists believe they may form inside dense star clusters, where repeated collisions slowly build something larger and larger over time. Intermediate black holes may be the first step toward objects so large they can eventually swallow entire solar systems. Supermassive black hole. At the center of almost every galaxy in the universe sits a supermassive black hole. Buried at the heart of the Milky Way is Sagittarius A*, a black hole containing 4 million times the mass of our sun. From Earth, its event horizon would appear no larger than a tennis ball sitting on the moon, and yet every star you can see in the night sky is orbiting it, including us. Right now, the entire solar system is racing around Sagittarius A* at more than 200 kilometers per second, and one full orbit takes 230 million years. The last time our solar system completed a lap around the Milky Way, dinosaurs didn't yet exist. In 2022, scientists captured the first direct image of a glowing ring of superheated gas surrounding a perfectly dark center where light itself disappears. For now, it's quiet, dormant, like a lion sleeping at the center of the galaxy. But eventually, even giants begin to feed again. Quasar. Feed a supermassive black hole enough material, and the entire galaxy around it begins to disappear in the glare. The disk of gas spiraling into the black hole heats to such extreme temperatures that it can outshine every star in its galaxy combined. These objects are called quasars, and they're the brightest sustained objects in the observable universe. The most powerful known quasar is consuming the equivalent of an entire sun every single day, firing jets from its poles that stretch across millions of light years. Most quasars belong to the early universe, when galaxies were younger, denser, and far more violent than they are today, but some of them are still out there. And the next object on this list turns a quasar into something capable of wiping out life on Earth without warning. Blazar. A blazar forms when one of a quasar's relativistic jets happens to point directly at Earth. Most known blazars are safely far away, but if one formed within a few thousand light-years of Earth, the results would be catastrophic. The radiation would begin stripping away our ozone layer almost immediately, exposing the surface of the planet to lethal cosmic radiation. No warning would be possible. The jet moves at the speed of light, so the first sign of its arrival would be the damage already beginning. Entire ecosystems would collapse beneath an invisible beam crossing the galaxy. And somehow, even blazars still aren't the largest things on this list. Ultramassive black hole. Some black holes become so large that astronomers had to create an entirely new category for them. Ultramassive black holes exceed 10 billion times the mass of our sun. The most famous is TON 618, a black hole so enormous that if it replaced our sun, its event horizon would swallow every planet in the solar system and extend billions of kilometers beyond Pluto. Every world you have ever known would already be trapped inside the boundary where nothing can escape. TON 618's gravitational influence stretches across hundreds of thousands of light years, and even objects like this may not be close to the largest black holes the universe can produce. SLAB, stupendously large black hole. SLABs are hypothetical black holes exceeding 100 trillion times the mass of our sun objects, so extreme that their event horizons could be larger than the observable regions between entire galaxy clusters. Light traveling from one side of a SLAB to the other would take longer than the current age of the universe to complete the journey. At that scale, the black hole stops feeling like an object and starts feeling like part of the structure of the universe itself. We don't know if SLABs truly exist, but mathematics doesn't forbid them. Somewhere in the dark spaces between galaxies, there could be black holes so large that human intuition completely fails to process them. Every black hole on this list has one thing in common: there's always a boundary hiding whatever is inside. The final object on this list has no boundary at all. Naked singularity. Every black hole hides something at its center, a point where gravity becomes so extreme that our understanding of physics completely breaks down. Normally, that region is sealed away behind the event horizon, hidden from the rest of the universe forever. Physicist Roger Penrose argued that this isn't an accident. He proposed that the universe itself prevents these broken regions from ever being exposed. But according to the same mathematics that predicts black holes, there may be a way around that rule. If a black hole spins fast enough, its event horizon could theoretically disappear entirely, leaving the center exposed to the universe. That's a naked singularity, a place where space, time, and physics stop behaving normally, with nothing covering it anymore. We've never confirmed one exists. Most physicists suspect some unknown process always prevents them from forming, but nobody has ever proven that. Which means somewhere in the universe, there could be a place where the laws of physics are visibly broken, open to space, with nothing hiding it from the rest of reality.